question is, the random variable y is equal to integral minus infinity to infinite w of t phi of t dt, where phi of t is 1 between the limits 5 and 7, 0 otherwise. And w of t is a real white Gaussian noise process with a two-sided power spectral density. SW of f is equal to 3 watts per H for all f. The variance of y is how much? Yes, you have to find the variance of y. Variance of y, sigma y square. What is the formula? Yes, you can write it as E of y minus y bar whole square. The simplified form of this is E of y square minus E of y whole square. Okay. So now given y is equal to integral minus infinity to infinite w of t phi of t dt. So now for this y, you have to find E of y square and also E of y whole square. Yes, here in the y, you have two things, w of t and phi of t. Phi of t is a constant function, leave it. W of t is, what is your w of t? W of t is, yes, your w of t is a real white Gaussian noise. As it is a real white Gaussian noise, yes, its mean is 0. Its mean is 0. Okay. So by taking that, yes, now I'll go for E of y. E of y. Okay. Yes, it is nothing but expectation of integral minus infinity to infinite w of t phi of t dt. So it is just move your expectation inside. Inside you have two functions, but phi of t is constant. So your expectation is applied only to the w of t. So it is phi of t dt. Yes, you know the expectation of w of t is nothing but the mean of w of t, but as w of t is a real white Gaussian noise, its mean is 0. So what is your E of y? E of y is 0. Implies what is your sigma y square? Sigma y square is nothing but E of y square. Now we have to find this E of y square. Okay. Now see, for the white Gaussian noise, they have given the power spectral density. Yes, W of f is equal to 3. Okay. So what it implies? And we know the power spectral density and autocorrelation function or Fourier transform pair. Yes, that is by Wiener-Khinchin relation. So you can write this Rx of tau as, yes, the inverse of this power spectral density as 3 into delta of t. Yes, because it's constant, the inverse is 3 into delta of t. Okay, then. So now we'll find what is E of y square. Yes, it is simply just substitute integral minus infinity to infinite w of t phi of t dt. Yes, another y, integral minus infinity to infinite w of, let it be t dash phi of t dash dt dash. Yes, integral minus infinity to infinite. As phi of t's are constant, yes, if you move this expectation inside, it will be expectation of w of t into w of t dash into dt dt dash. Yes, here we have phi of t and phi of t dash also. So now we'll go for the substitution of the limits for the functions phi of t and phi of t dash. Here the variable is changed. Just remember, we are considering this process as a Whiteson stationary process, your random variable or your Gaussian noise as a Whiteson stationary process. So now let us substitute this. Phi of t is 1 between the limits 5 and 7 and phi of t dash is also 1 between the limits 5 and 7. So 5 and 7, integral 5 and 7, expectation of w of t into w of t dash into dt dt dash, because these two becomes 1. Now if you see this expectation of w of t into w of t dash, it is nothing but your autocorrelation function of a Whiteson stationary random process. So it is, yes, it is Rw. Yes, it is the autocorrelation function RW of Whiteson stationary. So it is t minus t dash dt dash. So it is integral 5 to 7, integral 5 to 7. Yes, RW of t minus t dash is, yes, what is actually RW of tau? 3 into delta of t. So it is 3 into delta of t minus t dash dt. Okay, let us solve this first integration. So integral 5 to 7 delta of t minus t dash dt dash is nothing but your 1. So integral 5 to 7, yes, delta of t minus t dash into dt dash is 1. So it is 3 into 1 dt. Okay. So 3 into, yes, integral 1 dt is t between the limits 5 to 7. So it is 3 into 2 is nothing but your 6. So E of y square is 6. Therefore, your sigma y square, yes, here if you see sigma y square is nothing but your 6.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.